Alright, so here's your free response question of the day. So we're going to look at the real question, the actual question used in 2018, number 4. The height of a tree at time t is given by a twice differentiable function h. And so they give you a table of values where t is the years and h at t is in meters in terms of the diameter, right, of a tree. All right, so recognize that this is not a rate. So what's the diameter of the tree for each year? Okay, so use the data in the table to estimate the derivative at 6. Now, I don't see 6 here, but what would be the estimate of it? So understand derivative means slope. So if I'm going to estimate it at 6, I'm finding the slope around when t equals 6. So if I'm going to find the derivative at 6, can you find the slope around it? That would be 11 take away 6 and 7 take away 5. Now when you do that, what you're finding is meters per year. That's the unit. So I don't need to simplify it, but that is meters per year. And it says, interpret the meaning of what that means. So at time t equals 6 years, the rate, the tree diameter is growing. Or is it the height of the tree? It's not the diameter, is it? It's the height of the tree. So let's make sure I do that. Right. So at the time t equals 6, the rate the tree's height is increasing at what rate? You see that word increasing and decreasing? So it's increasing at a rate of that. And I'm not even going to pretend and care that I will simplify that. It is 5 over 2, but don't matter. But notice because it's a positive answer, that's why it's increasing. All right, that's A. We can do this, right? B. Explain why there must be at least one time between 2 and 10 such that the derivative is equal to 2. So between 2 and 10, the derivative must be equal to 2. Why? So if I look here between 2 and 10, and this is an A-rock, I-rock question. So what I need to do from 2 to 10 is find the slope to begin with. So that's the A-rock. So the A-rock from 2 to 10 would be 15 subtract 1.5 and 10 take away 2. I'm assuming if I do this work, it's going to equal 2. So 15, between what? 10 and 2, right? Oh, you need to find a place where the slope is 2. So does that give me the slope 2? So I'm not looking at that. Is there any interval that gives me the slope of 2? So if I look at 3 to 5, 5 to 7, 6 to 2, that is 4 divided by 2. So that's exactly what I'm looking for, right in there. So if I go 6 take away 2 and 5 take away 3, that gives me 4 divided by 2, which is 2. So I just found the average rate of change from 3 to 5 years. So the question is, why must there be at least one time there that the derivative is equal to 2? So this is called the mean value theorem. That there must be at least one moment when the average rate of change equals the instantaneous rate of change onto C. Find the absolute minimum. No, where am I at here? Part C. Here it is. Use a trapezoidal sum. So how does that work? A trapezoidal sum. And I'm estimating the sum between 2 and 10. So I'm going to go 2 and 10 of that. And I'm going to approximate what that is. and I'm approximating the average height of the tree, which is another word for average value. So to do the average value, I take that answer and then divide it by the bounds. So there's kind of two parts to it. So first of all, the trapezoid, and I'm not simplifying. So trapezoid starts with 1/2 as part of the formula. There is 4 subintervals indicated by that. So unfortunately, they're not equal intervals. Oh, that means each interval I have to do separately. So if I look at the first interval, the width or height of it is 2, 3 take away 2, that's 1. Remember, this is all divided by 8, what I'm going to come up with. Oh, it's between 2 and 10. Yeah. So between 2 and 3, that's 1/2. And then what are the 2 heights that I'm going to use, which is 1.5 and 2. I'm going to follow that pattern. So let's try it again. So it's 1/2. The next interval, hopefully I have room here. The next one is between 5 and 3. So that's 2. And then the 2 heights I'm adding are 6 and 2. Well, 2 and 6. Let's do it again. 1/2. Now it's between 7 and 5, which again is 2. I hope I don't run out of room. The 2 heights are 6 and 11. I'm going to squeeze this in. And then one more time, 1/2. Now it's 3. And the 2 heights are 15 and 11. And that's all divided by 8, and that's it. Do not simplify on this exam. Done. And it doesn't tell you to explain the meaning of it, of what this means, because we're not integrating a rate. It's not connected like that to the story. All right, part D. In part D, but this answer is in meters. So you could say the average height of the tree from t equals 2 to t equals 10 years is, let me just write that, and that's in meters. All right, last part, part D. The height of the tree in meters can also be modeled by the function g. So you have g at x is 100x and then 1 plus x. And it says where x is the diameter. This is the diameter part. When the tree is 50 years old, tall, the diameter of the base of the tree is increasing at a rate of 0.03. So the diameter is g at x, or the height is g at x, sorry, when the tree is 50 meters tall. So the height is that. I first need to figure out what x equals in terms of the diameter. It's not given. So I first need to solve this part to begin with, because I'm going to need that value. So let's do that before I do anything else. To solve it, I would simply cross multiply quick. So that's 50 plus 50x is equal to 100x. Subtract 50. Divide, and you can see x is equal to 1. Now what does that mean? So the height is 50, and the width, the diameter, is 1. So g at x is the height, and this is the diameter of the tree. Now, I want to do what? I want to know when the tree is 50 meters tall, and it's increasing at a rate of 0.03. According to what is the rate of change of the height? So this is what's called the related rate question. So I'm going to take the derivative of this at the beginning with respect to time. So the derivative of that with respect to time. So the derivative here is going to be the quotient rule. So the quotient rule is the bottom times the derivative of the top, but I need a hook that's to do with time. So every time I take the derivative of x, it needs a dx by dt. Then it is subtract the top times the derivative of the bottom. Now the derivative of the bottom is 1, but it needs a dx by dt. And then the bottom squared. Next, I'm going to do some substituting, and I'm not going to simplify this down. So I know that x, we just said, is 1. I know dx by dt is given. So in the question itself, it says the rate that the diameter is increasing is 0.03. That's given in the question, 0.03. So dx by dt is 0.03. And then just continue that. So where there's an x, 1, dx by dt, 0.03, and then the denominator is 1, and that's it. And so the question is, according to this model, what's the rate of change? So of the height of the tree. So this is meters per years. So this answer, and I don't want to simplify it, is the one in terms of how the rate of change. So at this is actually when the tree is 50 meters tall, the rate of change of height is, and then you could just write that all in, 1 plus 1 is 2, 2 squared is 4, and that is meters per year. And that's the change in terms of our rate. Hey, you got there? Thank you for doing your work. Mr. G Math, over and out. And until next time.